Today we're visiting the Palmit Pumped Storage Scheme, about 60 kilometers from Cape Town. Here we will learn how electricity is produced at a pumped storage scheme. At a conventional hydroelectric power station, the station is built on a river system. The water flows through a waterway to the turbines. Once the electricity is generated, the water is channeled back into the river. A disadvantage of a hydroelectric scheme is if there's been little rainfall that season, the water levels will be low and the station cannot be used to generate electricity. However, should the area have had sufficient rainfall, the station can be used for continuous electricity generation. In a water-scarce country, pumped storage schemes are used as an alternative to conventional hydroelectric power stations. Instead of the water being discharged, it's retained in the system and reused. Coal and nuclear power stations generate electricity 24 hours a day and are called base load stations. These stations cannot be switched on and off very quickly. There are times when large amounts of electricity are needed by consumers. These times are referred to as peaks and are normally in the mornings and in the evenings. During these peaks, quick reacting stations are needed. The pumped storage schemes fall into this category. The Palmit pumped storage system can supply an extra 400 megawatts onto the electricity grid within 4 minutes of startup. A pumped storage scheme consists of a lower and an upper dam. Between these two dams, a power station, which also doubles as a pumping plant, is located. During periods of emergency or peak demand, the water stored in the upper dam is released into large waterways to flow through the turbines to generate electricity. During off-peak periods when customers' demand for electricity has decreased, the reversible pump turbines use electricity from the grid to pump the water back up to the upper dam. As it's necessary to pump water back after use, pumped storage power stations can only provide electricity for limited periods of time. In addition, they're more expensive to run because of the pumping costs. These disadvantages are offset by their quick reaction to changes in electricity demand, which play a major part in maintaining the stability of the national grid. The upper dam is called the Rockview Dam. This dam has no natural catchment area and is situated on the watershed between the Palmit and Steenbras rivers. The lower dam is called the Kochelberg Dam and is located on the Palmit River, which provides the water used within the system. There's a waterway that carries the water from the Rockview Dam down to the Kochelberg Dam. This waterway is 2 kilometers in length, starting off at 6.2 meters in diameter and narrowing to 2.5 meters in diameter as it enters the turbine. You could drive a double-decker bus through this pipeline. The two 200 megawatt generator pump turbines are located 60 meters below ground level at the base of 2 concrete-lined shafts. This is equivalent to a 25-story building. The power station is built almost like a set of rugby poles buried underground. One waterway coming down from the Rockview Dam, splitting just before it enters the station, so that each machine can have water. The water flows into the turbine through an enormous valve, which weighs 180 tons. This valve operates like a tap to control the flow of water into the machine. The water passes into a spiral casing, which is a pipe that spirals around the turbine. As it spirals, the pipe narrows, building up pressure. Around the turbine are 20 guide vanes, which regulate the flow of water onto the turbine. The turbine always has to spin at exactly 300 revolutions per minute. The water pushes the blades of the turbine, which turns the shaft, which in turn spins the rotor in the stator, which then generates the electricity. The generator motors produce 16.5 kilovolts, which is then stepped up to 400 kilovolts by generator transformers installed in the high voltage yard just outside the station. 2 400 kilovolt lines connect into the national grid. Palmit is manned 24 hours a day and receives its instructions directly from the National Control Room in Johannesburg. National Control monitors the electricity supply and demand in South Africa. The power station operates on a weekly cycle. Power is generated at peak periods from Monday to Friday. The water used for generation is only partially pumped back from the lower Kochelberg Dam to the upper Rockview Dam every evening. Consequently, during the week, the level of the water in the Rockview Dam is gradually lowered. Over weekends, when the electricity demand is low, water is pumped back from the Kochelberg into the Rockview Dam to restore the dam to full capacity. Eskom has two pumped storage systems in South Africa, the other being the Drakensberg pumped storage scheme in the Drakensberg Mountains. A third station, called the Ingula pumped storage scheme, is currently being constructed in the Little Drakensberg range, straddling the border of the KwaZulu-Natal and Free State provinces. It will produce 1,332 megawatts of electricity when completed, and will help to relieve the pressure during peak times in an ever-growing South Africa.